Hello everyone, myself Akash Dixit, pursuing my BE at Sri Venkateswara College of Engineering. Today I'll be discussing about the topic Fourier transform and its application. The contents are introduction, properties, fast Fourier transform, applications of Fourier transform, its limitations and challenges, and conclusion. We shall begin with introduction to Fourier transform. Fourier transform is a mathematical tool used to analyze and decompose complex analysis of signals or functions into a combination of simpler sinusoidal functions. It was introduced by Jean-Baptiste Joseph Fourier in the early 19th century. The Fourier transform has applications in various fields like signal processing, analysis, audio compression, and quantum mechanics. Definition of Fourier transform. The Fourier transform of a function f of x is given by the function f of k is equals to integral f of x e power minus 2 pi I kx dx, where f of k represents the transform function is in the frequency domain. It transforms a function from the time or the spatial domain to the frequency domain. The Fourier transform can be applied to both continuous and discrete functions. Properties of Fourier transform. Linearity property. The Fourier transform of a linear combination of functions is the same linear combination of the individual transform. Time shifting property. Shifting a function in the time domain corresponds to phase modulation in the frequency domain. Scaling property. Scaling a function in the time domain leads to corresponding scaling in the frequency domain. Fast Fourier transform. The fast Fourier transform is an efficient algorithm for computing the discrete Fourier transform of a sequence or a discrete function. It reduces the computational complexity of the Fourier transform from O of n power 2 to O of n log n, where n is the number of samples. The FFT has revolutionized many applications that require real-time signal processing or large-scale computations. Introduction to Fourier transform application. The Fourier transform is a mathematical technique used to analyze signals and systems in the frequency domain. It has various applications in real-world scenarios, making it an essential tool in the fields such as engineering, physics, and telecommunication. This representation will explore some of the key applications of Fourier transform in the real world. Image and video processing. Fourier transform is widely used in image and video processing for tasks such as compression, filtering, and enhancement. It allows for efficient compression by representing images and videos in the frequency domain, removing redundant information. Filtering operations such as noise reduction or sharpening can be performed by manipulating the signal components of the signal. Audio and music processing. Fourier transform plays a vital role in audio and music processing applications. It enables tasks such as audio compression, equalization, and pitch reduction. By transforming audio signals into the frequency domain, we can analyze and manipulate different frequency components, leading to various audio effects. Signal analysis and its spectrum analysis. Fourier transform is extensively used for signal analysis and spectrum analysis. It helps in identifying the frequency components present in a given signal. Spectrum analysis allows for the identification of dominant frequencies or the presence of specific patterns in signals, aiding in various applications like speech recognition and vibration analysis. Communication signals. Fourier transform is fundamental to the design and analysis of communication systems. It allows for the modulation and demodulation of signals, enabling efficient transmission and reception of data. Fourier transform also helps in signal equalization, channel estimation, and error correction techniques in communication systems. Medical imaging. Fourier transform is used in medical imaging techniques like magnetic resonance imaging and computed tomography scans. It helps in reconstructing images from raw data acquired by these imaging techniques. Fourier transform aids in the enhancement and analysis of medical images, assisting in diagnosis and treatment planning. Radar and sonar systems. Fourier transform is utilized in radar and sonar systems for target detection and range estimation. By analyzing the frequency components of the reflected signals, these systems can identify and locate targets accurately. Fourier transform also assists in noise reduction and interference rejection in radar and sonar applications. Quantum mechanics. Fourier transforms find applications in quantum mechanics for solving Schrödinger's equation. It allows for the analysis and manipulation of wave functions, leading to a better understanding of the quantum signals. Fourier transform aids in the calculation of energy spectra and wave function probabilities in the quantum mechanics. Speech and audio compression. Fourier transform plays a crucial role in speech and audio compression algorithms like MP3. It enables efficient compression by removing redundant frequency components. By representing audio signals in the frequency domain, we can achieve high compression ratios while maintaining perceptual audio quality. This is the pictorial representation of the speech and audio compression where time domain S of t undergoes Fourier transform and given the output signal in the frequency domain. Limitations and challenges of Fourier transform. The Fourier transform assumes that the signals are stationary, linear, and have infinite duration, which may not always hold true. The presence of noise or non-linearities can affect the accuracy of the Fourier transform. Choosing the appropriate window size and dealing with edge effect are some common challenges in practical Fourier analysis. Conclusion. Fourier transform has a wide range of applications in various fields, including image and video processing, audio and music processing, signal analysis, communication systems, medical imaging, radar and sonar systems, speech and audio compression, and even quantum mechanics. Its ability to perform signals from the time domain to the frequency domain allows for efficient analysis, manipulation, and compression of signals and systems. The versatility of Fourier transform makes it an indispensable tool in the real world. Thank you.